All right, last video got cut off somewhere on the feedback on this, so here's the solutions. Okay, and then here's the domain and range. Remember, one has an open circle, so we don't include that parentheses, and one had a closed circle, so we do include those brackets like this. Okay, all right, last thing we're going to cover today is zeros of a function. In the last section, they word it this way: for what values of x, create the situation where f of x is 0 or something like that. Okay, but now we're going to call that zeros of a function. So what we need to do is just realize this also means just y is equal to 0. We replace f of x with 0 and then solve the equation. Okay, all right. So back to that algebra review again. I'm looking for factors in negative 12 that have a sum of the middle term 4. So I start investigating that. 6 and negative 2 are going to give me the sum I want. Okay, so I'm going to take these numbers now. Remember, kind of siphon it through this middle term and make that 6x and minus 2x. Okay, so now I factor out the GCF out of this group and the GCF out of this group. So 3 comes out and x comes out. And here I have to take out a negative 2. So fill in the blank. Negative 2 times x gives me that. Negative 2 times positive 2 gives me negative 4. All right, so this is a common factor, x plus 2. So now that's coming out of each of these basically binomials. So we get x plus 2. And once that comes out, what am I left with? 3x minus 2. Okay, zero product law to finish this. Set each of these two individual factors equal to 0 and solve them. All right, so we could say x equals, but they want us to call them zeros now because zeros are solutions to an equation. So zeros are going to be negative 2 here and positive 2/3 here. So there they are. It does say verify them graphically. It's kind of up to you. If you have a graphing calculator handy, by all means, do it. So here's what we could do. And you're looking for the x-intercepts, if you remember that from last year. But if not, we're talking about it right now. So what I do is go to y equals 3x squared plus 4x minus 4. And I can verify these right here. My zeros are the x-intercepts. Maybe you want to add that. Find the zeros of the function graphically. This zeros are at the x-intercepts. Which makes sense. Your first quiz of the year, I had you find x-intercepts by hand. What'd you do? I put y equals 0. You plugged in 0 for y. That's what we're doing right now. Plugging in 0 for y. So zeros are at the x-intercepts. So you can kind of ballpark it right now, negative 2 and 2/3. Or you could hit the trace button. If you have, remember doing that, pulls up this little spider, and this will give you the zeros as well. I go to calculate, and it's going to say 0. So we choose the left bound, hit enter, choose the right bound, hit enter, and then it gives me the 0 of negative 2. Okay, so an optional thing to do to verify it if you have the time and the resources to do that. Okay. Okay, let's go on to number 5. Replace y with 0 again. So we have this equation. These problems are just heavy on solving equations in a variety of them. All right, so we need to get rid of this radical, so we should square both sides. Okay, if that's going to look confusing to square it right now, maybe just write it down. Square both sides. Because we know when we take the square root of something and we turn right around and square it, they cancel. So that's our goal of doing that. That's why we're squaring both sides. Okay. All right, so 0 squared is obviously 0. And on the right side now I have 8 minus x squared. Okay, back to a quadratic. And when there's no x term in the middle, the square root method is the best. I could move the 8 over, but then I'd have a negative in front of x squared, so it'd be smarter to add the x squared to the other side. And then take the square root of both sides. So square root. So I have x equals plus or minus the square root of 8. Now remember, if you check this in the back of the book or if it's on a multiple choice test, it will be simplified. So we need to make sure we take the square out of that. There is a perfect square that goes into 8, right? We got 4 times 2. So the square root of 4 gets out. 2 stays in. So here's your zeros. Plus or minus 2 square root of 2. Okay. You won't have a chance to try these in the notes. You will in the OTI. So let's just bang out these last 2 problems. And here we go. Try it. Okay, 6. They're all a little unique. They are all a little different. Replace this with 0 again. All the stuff needs review, so I'm glad it's here again. But this process is a lot like some things we've done. All right, when something's in fraction form, I think the best way to get it out of fraction form is to continue to tell you to cross multiply it. So you might be wondering, well, 0 is not a fraction, but any number or whole number, we can always put it over 1 and make it a fraction pretty quickly. So if I just cross multiply this and set it equal, this will get it out of fraction form. So I say 5x times 1, which is 5x, but I'm just writing it down just so you see the cross multiplication, equals 0 times 2x minus 7. 0 times this expression wipes it out, so I just have 5x now equals 0, and divide by 5 to get the answer. Okay? So cross multiplying gets it out of fraction form. There is another way to do it. Some students might just see this and say, well, I'm just going to multiply by the denominator right now, 2x minus 7 to both sides. That also works. Cross multiplying is a good strategy, though. All right, one more. 7 looks like 6, but so that's why I'm going to replace it with something different here. Write this down, please, for number 7. X cubed minus 3x squared minus 4x plus 12. Okay, so when you have a cubic function in 4 terms, the grouping method works great for this. All right, so whenever I have a cubic function, I'm going to encourage you to use the grouping method. So by grouping method, I mean, look right here. See, we had 4 terms at number 4. We factored out the GCF out of each group. Chances are, if they give you 4 terms like this, it is going to be factorable that way. So factor. If you want to write off to the side, factor by grouping, go ahead. So I'm taking out an x squared and filling in the blank. So I need x minus 3 here. The next group, I've got to transfer that sign down in front of the next group. And then I got to take out a 4. So I need a negative 4 times negative 3 to get to plus 12. Okay. Oh, and I can also set this equal to 0 now, right? Because we're replacing f of x with 0. Okay, and now x minus 3 can come out of both of these to get x minus 3, and then I'm left with x squared minus 4. Okay, now this is a difference of 2 squares. I could also factor this one more step, make it x plus 2 and x minus 2. But if you didn't see it, and you set both of these equal to 0 and did the 0 product law, like we always do when we have this scenario, then it's going to work too, because we could use the square root method. So your call. I'll go ahead and set both of these equal to 0 right now. And solve them. So my zeros are, I get positive 3 here. And here, once I add 4, I don't know if you can do that in your head or not, but if you add 4, right, we get x squared equals 4, and then take the square root of both sides. So plus or minus 2. So zeros are 3, and plus or minus 2 for our final answer. Okay. Okay, so as far as we're going to get here today, when you get to problems like this, number 8 and 7, actually, I'll probably go through one of these for you here. Just a second. I'm going to pause. Okay, but I guess all I really want to tell you is just when they say use this graph to find the domain and range, there's multiple answers here. Domain, range, so you can do it just like we did here in the notes. And then they ask you a few questions about, reading the graph. When x is -1, what's y? And so on. So just do A, B, C, and D, and then you kind of have like an E and F because you're going to do domain and range for those two. Okay, so follow that format we did here. And then when you get to find the zeros of the function, I don't care if you use your calculator to verify, but it's not asking you to do that. So it's algebraically. So please show work to support your answer on this last set of problems here, okay?